We're continuing section 4.6. This time we are giving an example that is a rational function. H of x equal to 2x squared over x squared minus 1. Notice, what is the domain of this function? Domain of this function is where the denominator is not 0. So let's find the domain first. X squared minus 1 equal to 0 will give me x equal to plus minus 1. And so the domain is everything excluding, so it's the entire real line minus the point negative 1 and 1. Now, what else do we know about this function? Let's see what if there is an asymptote. There are two vertical asymptotes where I set the denominator. This is in the most simplified form, so I set the denominator equal to 0 and I get the two vertical asymptote, x equal to 1 and x equal to negative 1 are vertical asymptotes. Now, is there a horizontal asymptote? Let's look at that. Limit as x goes to infinity of 2x squared over x squared minus 1. And this is, we know from before that it's going to be the coefficient of the highest terms. If the highest the leading coefficient, the ratio of the leading coefficient, if the degree of the top polynomial and degree of the bottom polynomial are the same. What's the coefficient here? 1, so it's going to be 2. So y equal to 2, and the same thing works for positive infinity and minus infinity. Y equal to 2 is horizontal asymptote. A lot of good information came in. What else is there? Well, you can solve to find where the y-intercept is, and that's at x equal to 0. So 0 and 0 is a point. Is this function either odd or even? It's an even function because if I switch x with negative x and negative x, it would be equal to the original value. And so this is an even function. Even function means that it's even function. Even function means that it's symmetric about the y-axis. And y-axis. Now that I have all this information, I will try to use calculus to solve for the rest, for the min, max shape of the graph, basically. So let's start the calculus part. Now, to use the calculus, I have to take the derivative and I have to take the second derivative. The first derivative gives me critical numbers and increasing, decreasing, and possibly max and min. And the second derivative gives me the shape of the graph. H prime of x is equal to derivative of the numerator is going to be 4x and times the denominator. Then derivative of the denominator, 2x, and then divided by x squared minus 1 to the power 2. And then what you get and end up with is, if you distribute this one through, you get 4x cubed, and if you distribute this one through, you get minus 4x cubed. So what is left is 4x minus times minus 1, which is negative 4x over x squared minus 1. Now let's take the second derivative also, and then that would be derivative of the numerator, which is negative 4, times the denominator, then minus the numerator, which is negative 4x, times the derivative of denominator, which is 2, times x squared minus 1, the derivative of outside, times 2x derivative of inside over x squared minus 1 to power 2 to power 2, which is 4. Now, in here, I know that I'm going to need to find the sign for h double prime, so I better simplify this. Let's see what I can factor and what I cannot. I see the 4 is in common in both of them, and then I see that x squared minus 1 to power 1 is in common for both of them, and so I'm going to factor those basically. And so what I end up with is x squared minus 1 to power 4. What is left of that? And I'm factoring 4, x squared minus 1 to power 1. What is left in the first one is negative 1. Negative x squared minus 1. In the second one, what is left is basically 4 times x squared plus 4 times x squared. Now this one simplifies with that. This becomes 3, so I will have 4 and simplify this, and you get 3x squared plus 1 divided by x squared minus 1 to power 3. Oh, and notice that there's no zeros for h double prime. Therefore, sign of h double prime only depends on the denominator over here. Now let's try to, now that we have the two derivatives, let's try to find the increasing, decreasing, and all of the rest. First thing, the only critical number here is x equal to 0. The other numbers are not part of the domain. When I'm trying to find the increasing, decreasing, though, I have to put in the numbers that are not part of the domain, because those numbers also. So when I'm finding the sign for f double prime, even though they're not critical numbers, they're not part of the domain, they have to do with the change of sign for f double prime. So what I'm going to do, I'm putting in negative 1 over here, 0 and 1. Now that all of these are in the bottom, are put on the line, let's look at the little bit of the fact. If I put a very big negative number in here, the numerator is going to be very big, positive number, and then the denominator is going to be very big, again, positive number. So the entire thing becomes a positive number. However big or small, we know that it's going to be a very small number, but it's going to be a positive number. So over here it's a positive number. Then if I'm passing negative 1, if you look at the denominator, it's basically x minus 1 times x plus 1 to power 2, which is, I can write it in this way. So at negative 1, actually the sign does not change. So I'm keeping the same sign. When we are at 0, then the sign has to change, because x is to power 1, which is an odd order. So it's going to change. At 1 again, it's not going to change, because x minus 1 is to power 2. So both x at negative 1 and 1, the order are at 2. So what is going to happen is going to stay negative. So this is giving me the increasing, decreasing here. How is that happening? Increasing for f, it's increasing here, decreasing here, decreasing here. There is a local max at 0. Local max at 0. And -1 and 1, I don't know, I don't see any, I know that there is no local min or local max. So increasing at -infinity and -1 and -1 and 0, decreasing at 0 and 1 and 1 and infinity. Now let's try the f double prime and then put them all together. So for f double prime, what we have is this f double prime. Now for f double prime, I know that there is no root, and the points that makes the denominator 0 are the points that are not in the domain of the function, but I still need them to find the sign for f double prime. Remember, x squared minus 1 is x minus 1 times x plus 1 to power 3, each one of them to power 3. So the denominator is basically factored this way. And so there is no, and remember, this one has no real root. And so I have a -1 here and I have a +1 over there. And then I'm looking at it. The numerator is always positive, no matter what you plug in. So the sign is decided with the denominator. When we are when x is very big, negative number, absolute value big, negative number, what we get is a negative number over here to power 3 and negative number to power 3, so we get a positive value. As I pass -1, -1 is an odd root, so the sign changes. As I pass 1, 1 is an odd root, the sign changes. And this is how we have the signs. So the function itself is going to be concave up, concave down, concave up. Now let's put all of these information together and graph the function. So putting everything together, -1, 1, and 0, and first I'm going to put in the little tangent lines using an increasing, decreasing, or the directional tangent line, increasing before 0, decreasing after 0, and -1 and 1, and there's the breakage, so it's -infinity to 0. So I have a little piece here, little piece here, and then a little piece down here, a little piece down here. Now I'm using the f double prime to find the concavity. This one is concave up before -1, so I get this piece. Between -1 and 1, it's down. I get this piece and this piece, and then after 1, I will have a +1 looking like that. Now I can put everything together. So again, we knew that 0, 0 was a local max, 0 and 0 over here. I know between -1, so there is the -1 and 1, and then I have these two are the vertical asymptotes, and I have a horizontal asymptote that goes like this, y equal to 2. So what is going to happen is that I'm going to try to put in over here, I'm starting at 0. What is to the left of 0, but between -1 and 1 is going this way, and I know I'm supposed to go toward the horizontal asymptote, and over here goes this way. and I know I'm supposed to go toward the horizontal asymptote. In here, I see that I have to have this shape. So this shape cannot be under the, I'm sorry, the last two times that I said horizontal asymptote, I meant vertical asymptote. This shape cannot go under the horizontal asymptote, because then it has to come up and then the shape changes. Therefore, it has to be above the horizontal asymptote. So that's what I put in there, above the horizontal asymptote. And same thing here, it can go like this, therefore I have to put it up there. And that gives me the shape of the function, basically. And that's the graph of the function. A little better drawn, it looks like that.